Today we're going to solve the problem 24.64 from exam 2. The initial problem states that a parallel plate capacitor is made from two plates 12.0 centimeters on each side and 4.50 millimeters apart. Half of the space between these plates contains only air, but the other half is filled with plexiglass of dielectric constant, which is 3.40. An 18.0 battery is connected across the plates. So we have three parts to solve. Part A states what is the capacitance of this combination. Part B, how much energy is stored in the capacitor. And part C says if we remove the plexiglass but change nothing else, how much energy will be stored in the capacitor. So basically we have to start with the easiest part, with part A. To solve this part, we have to determine the formula of total capacitance, which equals capacitance of air plus capacitance of plexiglass. The capacitance of air itself equals epsilon multiplied by A, which is area of the plates that we have to find as well, and divided by the diameter, D. So to calculate the capacitance of air, we have to calculate the area of the plates first. So it is going to be 12.0 multiplied by 12 divided by 2, because it takes only the half of the capacitor. And all this equals 72.0 centimeters squared, which is basically 0.0072 meters squared. We do have the diameter already, which is 4.5 millimeters, which is the same as 0.0045 meters. So basically, having all these values, we can calculate the capacitance of air, and it's going to be equal epsilon, which is a constant, and air equals 8.85 multiplied by 10 to the negative 12 multiplied by the area of the plates, which is 0.0072, and all this divided by 0.0045, which is the diameter. And all this equals 14.16 picofarads, or 14.2 picofarads. So obtaining this value of capacitance of air, we have to find the total capacitance, which is going to be, as we know already, capacitance of air plus capacitance of plexiglass, but it can be rewritten as dielectric constant multiplied by capacitance of air. So it's going to be equal the value of capacitance of air that we found already, plus the dielectric constant, which is 3.40, multiplied by the same value. And this basically equals 62.30 picofarads. And this is the answer for part A. So this is the capacitance of the given combination. In part B, we have to find how much energy is stored in the capacitor. So basically, we have just to simply use the formula of energy, which is U equals 1 over 2 multiplied by C multiplied by V squared. And all these values we have already obtained, and the value of V is given in the initial value problem. So basically, it's equal 1 over 2 multiplied by 62.30 picofarads multiplied by 18.0 squared, and it's the same as 1 over 2 multiplied by 62.30 multiplied by 10 to the negative 12 farads multiplied by the same value of V. And all this equals 10.10 multiplied by 10 to the power of negative 9 joules. So this is the answer for part B, which asks us for the energy of this given capacitor. So part C, the final part, asks us for slightly different problem. So we have to remove the plexiglass part and find out how much energy will be stored in this new capacitor. So basically we have to obtain the new formula for this new capacitor, which is going to be capacitance of air plus the same capacitance of air, because we're going to have both parts of air instead of air and plexiglass because we removed this part. So simply calculating this, we will have 13.2 picofarads multiplied by 2, and this gives us 28.32 picofarads. And next step is just simply calculate the energy using the same formula we used in part B. So it's going to be 1 over 2 multiplied by C multiplied by V squared. And it's going to be equal 1 over 2 multiplied by 28.32 picofarads multiplied by 18.0 squared, and this is the same as 1 over 2 multiplied by 28.32 multiplied by 10 to the power of negative 12 multiplied by 18.0 to the squared, and all this equals 4.60 multiplied by 10 to the power of negative 9 joules. And this is the answer for part C. So basically we have solved all the parts, and summarizing, we have capacitance of the given capacitor, which is 62.30 picofarads in part A. In part B, we have the energy which is stored in this given capacitor, and equals 10.10 multiplied by 10 to the power of negative 9 joules. And finally, part C gives us the value of energy in the new capacitor without the picofarads part, which equals 4.60 multiplied by 10 to the power of negative 9 joules. So this is the final answer for all three parts of this problem.